Well, hello there and welcome. This is Aurora with Central Coast Astronomical, and I am so excited for tonight's presentation. We are going to be doing some stargazing tonight. We actually have a couple of surprises for you, and I am really excited we get to share our this is an informal time for us to look through a telescope and take a look at what's up in the night sky. We're going to hear from several astronomers as well in the chat and both as well as live, and we're just going to have a fun night together. So before we begin, I know we're a couple of minutes early. I'm going to introduce you to our astronomers for tonight. But before I do, if you could let us know where you are in the world tonight, and just let us know if you're outside the United States, please also include your country. Just drop that in the chat right now. Let us know, astronomically speaking. That will help us figure out what we should be talking about tonight. Tonight is very informal. In the past, as you know, we've had like big old handouts and have you guys, we've had a plan. Tonight, it's just more looking through a telescope, just like you would be doing in a regular public stargazing party. So that's our goal for tonight. We'll be on about 60 minutes. Roughly between 45 minutes and I'd say 75. We're going to aim for 60. I see everybody nodding. Yes, we're going to aim for 60. Anyway, so I'm really excited for tonight's presentation. Now, before we get started, if you could grab a pencil and a piece of paper, that would be great. You're going to write down the phone number that's right beneath me. If you have any questions, you can send us an email during this presentation. It's questions@centralcoastastronomy.org. Write that down. Or if you are watching us through something that uses YouTube and it strips off the chat, so you're not able to do the YouTube chat, we have email and we also have text. Please don't call that number. Nobody is actually here, but it will take your message that you're texting and send it to us in an email. So those are two opportunities to do that. We are going to be making that thing disappear during our presentation, so do make sure that you do write that down. So we have been busy. I have to be honest, it's been a busy, couple of years. And so we're really excited this summer. We are looking forward to getting together back to do live stargazing, which we're really super excited about. That's surprise number one. So we're going to be doing a lot of fun stuff. We're going to start to get back together. We're going to start to look at telescopes. This is going to be we're going to have a one or two more of these virtual ones, and we will be continuing them as well, just not as frequently because we're going to be live. Okay, so we have hello from New Jersey, hello from Darkridge, Tom, hi. We have Susanna from Solving. We have friends in Houston, Texas, and New York, and Washington, Colorado, more Washington, San Luis Obispo, the United Kingdom, Sydney, Australia. What time is it where you are? Just tell me what time it is right now if you're outside the United States. We have New Mexico, hello, Minnesota. No, there is no Zoom link. This is only on YouTube right now. Let's see, the screen is fuzzy. You might want to check your internet connection and see. So I have a good internet connection here. South Florida, hello. And we have a number of people. We've got, so I'm getting some emails as well. And so 3 a.m., 9 p.m., yay! All right, should we get started? I think it is officially time to introduce everybody to you. If you guys are ready, put a big grin on your face. We are going to go stargazing for the next hour, and we are going to have a blast doing it. Grab a piece of paper and a pencil. If we say something tonight you want to go look at, so you just have a place to jot it down. And we're going to be showing you views through a telescope, and then I will also show you where it is, so you know exactly where to go to look at the objects we're going to be looking at as well. I'm going to be using a program called Stellarium. You can find it at stellarium.org, and if somebody wants to drop that in the chat, that would be great. And so it's a free program. You can download it for free. There is also a printable star chart, which is hanging on the wall. You can get these from skymaps.com, and these are available free for your hemisphere. So whether you live in the northern or southern hemisphere, you click on the right one, you can download those. They're free as well. So these resources are free and easy to use. All right, so let's get started. Brian, let's bring you on first. Let's see if I can find you. There you are.
Here I am. Hello.
Hi, Brian.
Hello.
Welcome.
Thank you. Yeah, happy to be here tonight. I'm excited to show some telescope views. We've got some great objects.
Yes. Now you actually have a telescope. This is you at your. Where does your telescope go? That is actually your telescope, isn't it? Right there.
Yes, down lower left, the refractor. Yeah, that's an Orion 120 millimeter, and then I'm using an ASI 2600 from ZWO for the camera. It's a specialized astronomy camera. It's kind of like a video camera, but it's designed specifically for hooking up to a telescope.
Oh, okay, great, great. And anytime during our presentation tonight, if you have questions, you're going to type them in the chat. I want to say hello and thank you to all the astronomers that are currently on answering everybody's questions. So as many questions as you've got, go ahead and put them in the chat. Astronomers, you are welcome to answer all of them. Thank you so much for your help with that. And we also have another astronomer, but you're not going to be able to see him. He is our celestial advisor. He's our expert that's going to talk about what we see through the telescope. And you can see a picture of him right here with his big telescope. Kent, are you there?
I'm there, Aurora.
Hi, Kent. So how big is this telescope right there?
That's my 20-inch, or the mirror in it's a 20-inch mirror.
Awesome.
So that's pretty good size scope.
That is a pretty good size scope. All right. So Brian, we're gonna just start with you tonight.
Awesome.
What are we gonna be looking at?
We're going to look at M42 first, which is the Great Nebula in Orion. And shall we go ahead and
Yes.
cut straight to it?
Let's do
awesome.
it.
Yes, awesome. So here it is. This is the Orion Nebula. I would have to say this is definitely my favorite nebula. And this is in what appears to be the middle of the sword with the great hunter Orion. This is an amazing nebula because stars are being born right now as we speak. And most of them are being hidden by this dust that we see. What I really enjoy with it is just how it almost looks like a big bowl. And it's one of those objects where we start to get that impression of depth. This is considered an emission reflection nebula because not only is it reflecting light from these stars that are all around, but as well, it is emitting new light because the atoms are being energized and then putting off new unique colors. By the way, this is a combination of 17 minutes worth of 30-second exposures. So I have my camera taking 30-second clips, and then my program, which is called SharpCap, then adds them all together to combine the detail of the image without adding noise.
Wow, that is amazing. So Kent, what do you see when you look at something like this? What do you want to share?
In my 20-inch, right in the center, I actually see the trapezium, which is a group of 4 stars, makes kind of like a little square. And then all around that area, I see green from oxygen. It's really beautiful color-wise. And then beyond that, you really don't see red very well with your eyes, but around the edges, you'll notice there'd be kind of like a dirty orangish color. And that's really the H alpha part, or the hydrogen. H alpha is what's singly ionized hydrogen, and so that's what you see right in the center, the bright area of that image.
Oh wow! Now this is a pretty easy one to find, isn't it, Kent?
Oh yeah, definitely a binocular object. With my eyes, I never see it naked eye. I can see the sword hanging down from the belt there, but definitely with binoculars, you can tell there's something fuzzy there. And
Great.
That's M42, or the Orion Nebula. There's actually a little portion of it below that's actually M43. It's kind of like a little comet or a comma area. In this image, it's that little part at the top of the, that's M43. But mainly you say M42, you got the bulk of the thing.
Awesome. So if you are new to stargazing, so what you'll do, and actually this is something you could just do as long as your skies are pretty dark. You're going to go outside. Most people can find Orion. They can see those 3 belt stars here. So what you'll do is you'll find Orion, and then here, if I turn on the little sticks, this might be helpful, and the name of the constellation. So we have Orion here. This is his arm club and shield bow thing here. So you're just looking here for the 3 belt stars, and then you're going to go down to the sword, and it's the middle part of the sword that you want to be looking at, and that's what you're going to see. And so you're not going to see these beautiful colors though, right guys?
Not with binoculars or the naked eye. you've got to get up there in aperture. My 8-inch, I can't recall seeing any color in my 8-inch either. It's just when I first bought the 20-inch, I rolled it out for first light, and that's when I saw the green around the center trapezium.
Okay.
And I knew I had a good scope at that time. That was like spring 1995 is when I bought the 20-inch.
Awesome. So, Brian, what are we looking at here? Uh-oh, you are muted, Brian. Let's see if we can get you back.
Thank you. Gotcha.
You go.
What I've done is I've increased the magnification within my program, because I wanted to be able to highlight the wisps that you could see of these clouds of gas. And now, amazing to think that we are able to see this in so much detail, with it being 1,344 light years from Earth.
Wow.
And so one other thing I wanted to point out is that this nebula is actually part of a huge region of space. By huge, I mean covering a lot of the Orion constellation. It's called the Orion Molecular Cloud Complex. And the next area that we're going to look at is also part of this complex. And what that name denotes is these large areas of star-forming regions that we look when we're looking towards this area of the sky.
Nice. And so we don't see color with our eyes. It's because you've got a photograph here. So,
right.
Oh, one other thing.
Yeah.
You know that little red thing with the star in it?
Mm-hmm.
Right into the left there. That's M43. So I just wanted to point that out. When you compare it to all the rest, it's pretty small in comparison to
just a little
M42.
section. And then, by the way, Kent mentioned the trapezium, and that's in this area that's blown out or overexposed. And that's one of the catches with live images like this. It's a lot better than our eyes because we could collect light over time. But then to really appreciate this, then we would take these images into other software that can dynamically balance out the range to basically cut down the overexposure. Oh, by the way, sometimes you'll hear about the Running Man Nebula.
Yes.
And that is this region over here. But because of the filter I'm using, which we're going to talk about in just a moment, that's very difficult to make out because we've limited severely the wavelengths of light that I'm letting through to the camera.
Oh, wow. Now, what filters are you using?
Very good question.
I want to know.
Yes. So to share that, I'm going to actually switch to a different view so that I can share with you a little bit of information. So first, before I answer that question of what filter I'm using, I wanted to share with you that I'm using what's called a one-shot color camera. And that means that it's like the cameras we use on our cell phones or regular single lens reflex cameras. In other words, it's bringing in red, green, and blue all at the same time. Serious astronomy cameras are actually black and white, or monochrome, as we would say, and they use a red filter, green filter, and then blue filter, and then have to combine all three of those to get a color image. I use one-shot color for live. But what I've done, then I'm using a special filter from a company called Optolong. It's called the L Extreme. And so what it is doing is it is only letting through two very thin bands of light. If you picture the spectrum like a rainbow, if you picture a rainbow, then that covers all of the visible colors that we can see. But then those are divided into a wavelength, which defines the color. So what we're doing is we're letting through a very thin sliver for oxygen 3, and then a very thin sliver for hydrogen alpha, which Kent mentioned. And that's why we're getting so much enjoyable red, because this H alpha comes off in red, and then the oxygen 3 is green. And the last object we'll share tonight is primarily going to be visible in the oxygen 3.
Oh, cool. I can't wait to see that. Nice. And so when you're stargazing, you have filters as well, even though you're not doing photography, right?
Yeah. In fact, I've got probably the best filter for looking at planetary nebula is the oxygen 3. And there's one really basic reason that wavelength, which is about 5,000 angstroms for the filter, it's got a little window around 5,000 angstroms. That's actually really close to the peak sensitivity of our eyes. And so when I move the filter between my eye and the eyepiece, if there's a little planetary nebula there, it'll pop out of nowhere when I'm doing it through the filter. When I pull the filter away, it disappears. They call that blinking.
Okay.
So you just kind of move the filter between your eye and the eyepiece, and there'll be a little disc there, and then it's gone. Then there'll be another little disc again, and it's gone. That's pretty much how I use the oxygen 3 filter.
Okay.
They've got some other fancy filters like UHC and H-beta, but I figure for this talk, the oxygen 3 would be the one to cover.
Yeah. Yeah.
And it is a really useful filter. If you using it visually, it's best to throw a dark cloth over your head, because even the starlight coming over your shoulder, if it hits the front of the filter, it'll actually degrade the image or reflect right into your eye.
Oh, wow.
And
Okay.
so it's, when you use an O3 filter, it's very important to have a dark cloth over your head just to block any incoming starlight.
Oh, wow. Good to know. Oh, Brian, it looks like the echo thing got fixed, so we're good.
Okay, great.
Yeah.
I'm glad. So I'm not sure what it would have been.
It was me. I was hearing me coming through you.
Oh.
I already hear me enough. Okay, so have you? Do you have enough time that you got the next object ready to go, Brian?
Almost. Yes.
Almost,
I just
okay.
want to frame it just a little bit.
Sure, no
So,
problem.
okay.
Let me voice a couple of questions that have been coming in.
Sure.
So one of the questions is, if you are stargazing, do you? So if you first start to stargaze, I guess the question. Let me rephrase this question. How do you get started stargazing?
How do you get started stargazing?
You join us.
Yes. So that's a very good question. And I would say, not to be facetious, but you start by going outside and gazing at the stars. And what's amazing is you can enjoy so much simply by going out on a dark night and starting to learn the constellations. And now as we start to move into spring and then summer, when you're in a dark location, then you'll be able to enjoy that the Milky Way going right across the sky. And then I would say after that, and Thomas Smith said online or on the chat, you start by looking up. and then even just remember too, it's no matter where you're at, just stop and look up for a little bit and see what stars you notice. But then after that, if you get a pair of binoculars, and when you get the free sky map, for instance, that you mentioned, skymaps.com, that'll give you some naked eye objects, which means you don't need anything but your eyeballs. And then it'll give you some binocular objects so you can get started. And, we're using some pretty serious equipment tonight, but you definitely do not need to start with this. And you can just really enjoy the night sky just by going out with your own eyes.
Exactly. Okay, great. So we have some people that are guessing what we're taking a look at.
Yes. What could it be?
What could it possibly be? It looks really dim.
Well, yes, it does. And that's because it is. Now, one of the things to remember as we look through all of our images tonight, that I'm using this special L Extreme filter that's only allowing a very thin sliver of red and a very thin sliver of green. And so this will look different than what you might see from some, let's say, processed images. And that's because I'm specifically using this filter so you can see more contrast, but it may not pop like it does. That's why we start with the showstopper M42, and now some of these will be more subtle. The Horsehead was actually my favorite to see pictures of, and I was saddened when I went to a telescope and could not see it. And this is a remarkably dim nebula. In fact, it is considered a dark nebula.
That's what it's called, right?
Yes, it is. And so when you think about it, that shape of the Horsehead is actually formed by thick dust in the foreground, and it's blocking the light of stars behind it. And it's the stars behind all of this that are illuminating the hydrogen gas which gives us that red glow. But the most of the detail that we see, and if I zoom in just a little bit, it's really because of because of the dust that's giving us the noticeable horsehead.
So questions popping up about this one. Is what is causing that shape? Is it giving off light, or is it behind it, or what?
Yes, right. So think of this as if as basically it's being backlit. So if you start from us, we are now looking towards that area of the sky, and first thing we would come to is huge collections of dust. Then behind that is hydrogen gas, and then behind that and within that gas are stars. And so that's how it all puts together. The stars are putting off all of their energy from ultraviolet to infrared, everything in between, and that's energizing the hydrogen gas. If we did not have the dust, then it would be a big red glowing nebula. But because that dust is there, that to make it more enjoyable is in the shape of what we would call a horsehead, then that gives us that silhouette. So it's almost like a shadow puppet, really, as if there's a giant hand up there making the head of a horse, and that's the shadow that we're seeing essentially that causes that shape.
Oh, wow. Now, Kent, is this one easy to see with a telescope, or what would you say?
I've seen it in my 20-inch without any filters.
Oh, wow.
The thing you have to remember is it's actually pretty good sized. I'd say it takes up maybe around a quarter of the field.
Okay.
And so you have to be ready for that. But the only reason I was able to see it was just due to the sheer amount of aperture that was thrown at the horsehead there.
Got it. And so I've got on the screen now, I don't know if you can see it, I've kind of zoomed in on the leftmost, I don't know, which direction are we in
It's
now?
the easternmost star in the belt.
Yeah,
there.
thank you.
I can't remember its name either, but
yeah.
that's what it is. It's the easternmost star in the belt.
Yes, that's the one right there. And you just zoom in there and you look around and you got all kinds of interesting things here.
Yeah, it's upside down.
It is. I know. It's just my computer program.
Yeah.
Well, but, in a big reflector, it's actually right side up because everything's reversed.
Oh, that's right. I remember that was the most frustrating thing. The first time I looked through a refractor, because the eyepiece was different from the finder scope.
Yeah, that really throws you off
true.
when that sort of thing happens.
All right, we have some questions about this. Oh, looks like they are getting answered. Oh, yes. Dave Majors, I've never seen it in any scope. well, at least seems like you need to come out again with us with Kent, doesn't it seem, Dave? Zeta
I
Orion.
have to admit, I was out at Navajo Flats, which is a pretty dark site for our county.
Yeah.
When I saw it, so it wasn't at our normal top of the hill at KOA camp.
Mm-hmm. Awesome. And other questions? Yes, somebody asked what the designation, what Messier number this is. It's not. It's
right.
It's B33, I think.
You're right.
For Barnard.
Nice.
Yes, indeed.
Barnard did a catalog on Dark Nebula, and forget how many B numbers there are, but it's usually Dark Nebula are designated with a B, and then I think that one was number 33. Mm-hmm. It was actually found by Wilhelmina Fleming. She was part of the Harvard group on a photo, and she's like the first one to go, hey, it looks like a horse head. And basically it's stuck. But that was, I think, the turn of the century, sometime around there.
Mm-hmm. Now, when I was zooming in on Orion here, I happened to notice there was another thing in here. Brian, you have a picture.
Yes.
You have a picture of this that you've taken that's on your, I think I have a picture of it somewhere.
Yes, indeed. Yes, that is what I've shared before. And it is the next object we'll be going to as well.
Oh, it is?
Yes.
Oh,
yes.
Well, that worked out. Okay.
Yes.
We're spending a lot of time on Orion here.
We exactly. Yeah, this really almost could have been called the Orion Tour, at least for one more object, and then we'll move to Monoceros.
Okay. All right. Are you ready to? Oh wait, no, you're not.
I am, but there's so many questions. I think we've really piqued interest. Do you want to cover a few more questions?
Let's do that. Okay, so why is the dust not moving? Why can't you see the dust moving? Do you want to?
Yes, dust. It's all about the dust.
It's all about the dust.
Keep in mind how ridiculously giganto-huge these objects really are. This is about 1,375 light years away from us. And we are only able to see it because we're so far away. If you're up close, don't let science fiction movies fool you. We would just see maybe a little bit more dust than what we see in any other part of space. We have to be back farther to see it. But this is so far away and so huge. These things are actually moving. Stars actually do move from one position to another. Dust is moving, but the gas is moving. But it's so far away, we cannot recognize that motion in the lifetime in many of these things. Now, we do have examples of stars where for instance, we look back at photographic plates from 100 years ago and we can see things that have moved. Mm-hmm. But for the most part, it's just because it's so far away and so big that it's not noticeable to us.
So then the question that was piggybacking on that one was, will the shape change over time?
Yes, it will. Who knows what animal could be next? It would, by definition, it's in motion, so it will change. But these are very huge time frames, so definitely not in a human lifespan or many human lifespans.
Yeah. Okay, I'm checking email right now. It looks like we've got. Oh, people are taking pictures of Orion right now and sending them in.
Oh,
wow. How fun. Okay, people are stargazing with us. That's exciting.
Yes, that's awesome. Very nice.
I think that's most of the questions here. It looks like the other astronomers have answered most of them. So
okay, great. Yeah. So I'll go ahead and switch to the next object,
okay, great.
Which is actually all I have to do is zoom out because I purposely closed in on the Horsehead Nebula, but it's actually right here in my same image. With the refractor, I have a nice wide field of view.
Oh, wow.
And so let me just go ahead and share this first, because this would be the wide field view showing this region, but I want you to, or everyone to be able to enjoy. Sorry, I should stop talking for a moment to get my settings right.
That's okay.
25. Okay, so notice how far the red glow goes. Way up here. It may or may not be coming across for you, but this is all hydrogen gas way, way up here. And so then let's go ahead and close in on the Flame Nebula. And that's right here. Now, this is another time, I'll probably be reminding everyone a few times. Remember, thin sliver of red, thin sliver of green. When you look at images that are showing the full visual range, then this will look more like fire, giving you that understanding of why we call it the Flame Nebula. But because we're only looking at that thin hydrogen alpha, we're only seeing that red. Okay, now
I've got a little bit to throw in on that one
please.
Also. I've seen infrared photos of the flame, and it looks entirely different, but there's a ton of little protostars embedded in that nebulosity that infrared will pick it up, but visual you won't see it. And so that's a big star birth area right there. In my 8-inch scope, I can easily see the dark lanes running through the flame. And so it doesn't take a really big scope to see a lot of detail on that nebula.
Oh, wow. Awesome. So just to reiterate, got a couple of people asking, where is it? So again, we're just looking at this star in Orion's belt. So if we take off the labels and all stuff like that. Oh, wait. I wish there were lines connecting the dots. I really do.
When you go outside and look in the sky?
Yes.
Yes.
So most people can find Orion. You're just looking for those 3 really bright stars. And then we started M42 down here. And right now we're looking in this area. So just kind of zoom in here. Here's your Horsehead, and there's the Flame Nebula. So everything is all in this nice little package right in here. And you will not be able to see the flame with your binoculars. So I'll handle that question.
You know, one thing, when I was teaching myself the constellations, that's where I started, was the 3 in the belt. And I had H.A. Ray's book that has really good overlap. And so I started with the 3 in the belt and, you know, worked out the shape of Orion. Then I started moving eastward to like Sirius. And so that was my starting point when I was teaching myself the sky.
So you're just doing a little at a time, recognizing patterns.
Actually, I was staying up till like 3 o'clock in the morning.
Okay, well, you got the bug bad. Oh, awesome. So, Brian, did you want to share anything more about the flame?
Let's see, it's a couple of things. Yeah, I'm glad, Aurora, you pointed out that star. This would be Alnitak, which is that what appears to be the leftermost from our view. And Alnitak is, we consider to be responsible for most of this glow that we're seeing. So, for instance, it's shining ultraviolet light. It goes into the cloud of hydrogen gas, which excites that gas, causing it to emit this red light that we see. And so we're considering this nebula also to be about 900 to 1,500 light years away. And yeah, and the count that I had seen, they're estimating to have about 800 stars hidden in this region.
Oh, wow.
And what's fun is the counts change. Now, with all this dust, you wonder, well, how do we know there are stars here? What's amazing is we have X-ray telescopes. For instance, this Chandra X-ray telescope. And X-rays are, with X-rays, we can see essentially through the dust, and we can then see the stars. It essentially makes the dust transparent. So it's with X-rays that we're able to learn more about what's going on within the shroud of this gas.
I actually have a picture of it right here. There we go.
And this is the flame?
This is, it says the Flame Nebula.
Yeah,
I'm pretty sure it is.
Different.
Yeah, it's one of those images that is not visual.
Yeah.
It looks a lot different than visual image.
This does not look like what you're showing us, but we can see this because we are looking in a different part of the spectrum. Different light information is being recorded, so we can look at that.
Yes. Awesome. All right. Well, we're going to shift gears, Aurora, I think, for a moment. So I want to share, I like to share a NASA mission. So as a solar system ambassador, I get to learn so much about so many missions that NASA and other space agencies are participating and instituting. So I wanted to share one with you, but we don't want to get rid of our telescope views. So I'm just going to switch to a screen so you can see my presentation, and then this will just take a couple minutes. But I'm hoping that with what I'm sharing, this will pique people's interest on another mission so they can learn more. All right. Sound okay?
Yes. You look great.
Awesome.
Good.
So we have the Flame Nebula on the left, and then we're going to talk about Parker Solar Probe a little closer to home. So NASA has a mission occurring right now called the NASA Parker Solar Probe. And it was launched on August 12th, 2018, and is named after a heliophysicist, in other words, someone who studies the sun, named Eugene Parker. Now, I'm excited to share that Eugene Parker did live to see this mission launch in 2018. Oh, wow. Sadly, he did pass away earlier this month. But it has quite a legacy of helping us learn more about the sun, which now this mission of his namesake is going to help us learn anything more, or so much more. In fact, we're expecting textbooks to be rewritten with what we're learning from this.
Yes.
Now, this one launched from Cape Canaveral, as I mentioned, in 2018. And of course, across the approximate 7-year mission, it will orbit the sun 24 times. Now, this orbit is quite amazing because it now actually has as we're speaking, touched the corona of our sun. And we'll talk about that a little bit more here coming up. But let's talk about the orbit. Now, I know that this may end up being a little bit smaller on your screen, but just to make sure that you can see this, here's the sun right in the middle. And then moving here, this first ring, that's the orbit of Mercury. And the green and red loop are the orbital paths for the Parker Solar Probe. So this is going way, way inside the orbit of Mercury. In fact, it's designed to swoop within 4 million miles, or about 6.5 million kilometers, to the sun's surface. Very, very close. And at its closest approach, it's going to be moving about 430, gosh, to say this right, 430,000 miles per hour, or 700,000 kilometers per second.
Wow.
It's really going to be booking. And so what they've done is they've designed it to have assists from Venus to help adjust its orbit. And then it's going to come in and dip its toes, so to speak, into the corona and then come back out, moving very, very, very fast. And on December of just last year, so this is March 2022. So December of 2021, NASA announced that the Parker Solar Probe touched the sun's corona. This is the first time a human-made craft has done so.
Wow.
So it is now the craft that's been closest to the sun. Any questions before I go on to the next little tidbit?
No, the only one I got is it nearing the speed of light? And
so funny. Yeah, that would be awesome if we could, but yeah, nowhere close. Even that fast, just nowhere close. It's pretty amazing how fast the speed of light really is.
Yes.
Yes.
Keep going.
All right. Oh, incidentally, this orbital map right here is from Parker Solar Probe at the Johns Hopkins Applied Physics Lab, and this is updated every day. This is where the probe was about an hour ago with this green dot right here. So if you ever want to go to this webpage, you can see where the probe is at any given time. All right, now you may think about this. Hang on a moment. If we can't even look at the sun without injuring our eyes, how is this going to be touching the corona? And how is it going to get that close? Well, the probe is designed to always have a shield facing towards the sun. This is a special carbon composite shield that's about 4.5 inches thick, or almost 11 and a half centimeters. And so think about this temperature difference. On the sun side of the shield, it's expected to reach 2,600 degrees Fahrenheit. I wonder how fast you could bake a cake. Or 1,400 degrees Celsius. But on the payload side, which is where all the equipment is, it's going to be about 85 degrees Fahrenheit.
Wow.
So that is quite the shield. And so now with this shield, then that is what is allowing the Parker Solar Probe to dip into what is essentially considered the sun's atmosphere. Now, we want to keep in mind the sun, what's called the heliosphere, stretches out quite far. In fact, we technically are within the influences, of course, of the sun. That's why we have a solar wind. And if anyone's curious more about the sun, the Parker Solar Probe page with NASA is a really great place to start, because you'll start to learn so much more.
Yeah, I just posted it in the chat.
Oh, perfect. Thank you.
Uh-huh.
All right. Now, in fact, mentioning the sources, here's a couple of really good sources. I'll just have them up on the screen so people from the recording could see these two links, and then we could go from here with more details. So I hope that with that little tiny presentation with Parker Solar Probe, it'll pique everyone's interest. You can go and learn more about this and all the other amazing missions that NASA's partaking in.
Awesome. That sounds great. Yeah, the question was how hot is it and how is it not melting is what people were asking.
Oh, yes, and that's that sun shield. Yeah.
So I'm glad you mentioned that.
Awesome.
And corona, it's corona means crown, and the sun's corona was named a long time ago, and it has nothing to do with biology that we are all familiar with for the past few years. Okay. So that was
Awesome.
another question. Let's see. Other questions. Let's see. You can use the website that I posted to find out more information about it. So great. Yeah. Brian, it was Brian's idea to talk about space mission just a little bit each time, so we can, because there's so many. Just to kind of keep you up to speed on what's been going on and all the new discoveries that are happening.
And I'm trying to choose missions also that haven't necessarily hit quote unquote mainstream news, right? Because everyone covers Mars, it seems like. And I might still do some Mars missions, but we're also going to be sure to cover some of these others because like you said, there are so many.
Yeah, exactly. Now you've got a couple more objects you want to share with us. Is that right?
I do indeed.
Let's
yes.
do one. Let's do one.
So awesome. I am building my image stack right now for the Rosette Nebula.
Okay.
And so let's go ahead and share this.
Okay.
So here we have the Rosette. And this is one, I need to, definitely need to reset that one moment while I reset my settings.
Here, while Brian is doing that, I want to just give a quick shout out to our astronomers that are handling all of the questions coming in. Thank you. And if you do have questions, feel free to drop them in the chat anytime during the class. And also you can, we'd love to get kudos. So feel free to tell us what we're doing well that you like. So we like that too.
Yes, I like kudos.
We appreciate those. All right, Kent,
Awesome.
What can you tell us about the Rosette?
Okay, the Rosette is pretty interesting. You can see that little group of stars that are kind of towards the center. There's like 6 that I usually look for. And you can see there's kind of a hole opening up there. Those stars are actually blowing a hole in the middle of that nebula. You look around the edges, you can see some of the dark lanes radiating away from the Rosette. But the radiation pressure from those young stars will eventually disrupt that entire nebula. But it's going to be a long, long time in the future. We're talking about, hundreds of thousands of years. But eventually, there'll be a nice little open cluster there with no nebulosity. It will have been pushed away.
Awesome.
Yeah. So here's the image ready to go. And what I'm going to do is zoom in, so to speak, with my program a little bit closer so you can see the amazing detail that we end up with, the dust tendrils, so to speak, that we can see in here. It's pretty amazing. The dust breaks up the appearance so much of this nebula that the cloud of gas is actually divided into 4 different NGC numbers, being New General Catalog.
Oh, wow.
And then the 5th number that's associated, as Kent mentioned, is for the open cluster that's right in the middle. Yeah.
With my 20-inch I've got a 2-inch O3 filter that I can screw in the back of my big 32-millimeter eyepiece. You can actually see the dust lanes running through there using, that it's a low-power, wide-field eyepiece. And, I was really amazed you could actually physically see those visually.
Wow, that's awesome. Now, is this one difficult to find, Kent? I don't know how I would star hop here.
Actually, I found it with binoculars, so it's not that bad. If you look at, like, the 2 upper shoulders of Orion there, you've got Betelgeuse, and I don't remember the name of the other shoulder.
Bellatrix.
So you kind of draw a line eastward through Betelgeuse, and that gets you in the ballpark. And you just kind of scan around there with your binoculars.
Okay. So I think this is it right here.
Yeah, that's it.
Is that it right there?
If you blow it up there, you see the hole in the center and the open cluster there.
Yeah. Okay, so let's go back so we can find it. So for those of you who are new to stargazing, let's go for a walk outside. Let's shake it up. Here, let's go for a walk. You tell me when you see Orion. Where do you see Orion? Dun, 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 dun. Do you see him anywhere? Not you, Kent. I know you can see Orion with your eyes closed. There we go. All right, he's right in here. Can you point to where you would look for M42? Okay. And now, where would you look for the Flame Nebula if you had a telescope like Kent's? Where would you look? Yeah, you'd look in here. Okay, good. And now, where would you look for the Rosette? Where would you look? Okay, so we're going to connect these two here. So Bellatrix and Betelgeuse, we're going to connect those, and you kind of just start cruising around here, and you will see him right there. Nice. I like how you kept everything in one area of the sky tonight, Brian.
Yeah, definitely. I thought that with these objects, it would be, of course, I wanted it to be a nebula theme.
I could tell.
and part of, because with the exciting things we're doing with schools lately, then we're having each presentation on a certain topic. And by the way, I wanted to mention this nebula is huge. So it has an apparent size of about 1.3 degrees. So the moon, full moon, is about half a degree, right? So this is almost 3 times the apparent size of the moon when we're looking up at the sky.
Oh, wow. Now,
So
is
it is big.
is this a binocular object, would you say?
Well, I think, Kent, you mentioned that you've seen it, right, in binoculars?
Yeah, I've seen it with my 750 binoculars before from
Wow.
a dark sky site.
Those are, so that would be the trick.
It doesn't look like much, but I picked it up.
Yeah, I find the contrast to be much lower definitely than the Orion Nebula. And so this is one where you want to make sure your eyes are dark adapted and you're in a good dark site. And then, it's because it's such a wide area, it does lend itself towards being binoculars, but you want to be patient and definitely be familiar with where it should be.
Wow.
Yes. All right.
That's amazing.
So, let's see. But there's one other thing. This object, we're estimating about 5,000 light years from Earth. So the light that we're capturing right now left about 5,000 years ago.
Now, did you want to answer the question about, is this a star that exploded or a star that is being formed?
Very good question.
Okay.
So far, and what a very good transition question also, or segue for my next object.
Yes.
All the areas we've been showing of the sky are star forming regions. So we would also call these nurseries. And in fact, the open cluster that we see, it is believed that those stars formed out of this cloud of gas. So these are not explosions, rather, but compressing of gases into suns that are now fusing hydrogen to make helium. So they're moving from being newborn stars into what we call main sequence stars, which describes the process where they're in a stable manner fusing hydrogen into helium and keeping a relatively stable size.
Yeah.
So the next object
Wait.
to be...
Don't go yet.
No, I won't go there. I was just going to say,
Okay.
It'll be an example of a star that's at the end of its life.
Oh, okay, great.
start to set
Tom
that
Fry was... Wait, go back.
Oh,
I'm
sorry.
not done with you yet. Get back here.
Okay. All right, I am.
Tom Fry was asking, what is the blue nebula to the right of the Rosette? Why is it blue and not red? Blue nebula.
I don't see a blue nebula right now. So that's something that's on this that you're seeing on my image.
Aurora, I think it was on your sky chart image.
Oh. Was it in Stellarium? Okay, hang on. Then we will go back there. So we were on the Rosette. Why is it blue, not red? Okay, here. If I share my screen, maybe we could take a look.
Now pull way out.
There's one.
So we want to know what that is?
It's a reflection nebula, but right off the top of my head, I can't remember what it is. See the nice blue color?
Yeah.
Definitely, that's what a reflection nebula is. It's reflecting blue light from those stars off of the fine dust.
And getting Stellarium to tell you what something is near impossible. You have to click it right where it's sensitive. Oh, dark nebula, it says. But that could be something over here.
Yeah, in fact, you can see the dark nebula. They're kind of off to the right and upper.
Yeah. Okay, cool.
So there's a mixture there of reflection and dark, but I don't know what the NGC number is.
Yeah, here, let's see if I can grab it. No, I don't know. Oh, wait. Yeah, it's just got a whole bunch of all the dark. I can't get it. So yeah, the stellarium is great for some things and not so good for others. And then Dave Major's comment says, if Kent can see it in binoculars, the rest of us need a telescope. Okay, so all right. Okay, now you can go. So
okay, thank you. I wanted to do a quick clarification from a question that we had on the chat.
Yeah.
People were wondering then if stars are forming from the dust, because I mentioned how dust is creating these dark lanes. Mm-hmm. So the way to think of it is dust is literally just particles of matter. But then also there are large amounts of hydrogen gas, and it's actually the hydrogen that is compressing together to form the stars. So we would say the stars are forming from the gas. There definitely is a lot of dust, but then maybe sometimes we talk about planet formation, that's where the dust can come in handy as each star starts to have a gravitational influence.
Awesome.
All right.
Okay,
so I'm going to switch back here so I can set up my next view. So this will be our final object of the night.
Okay, so let's, here, while you are viewing it, so Kent, how do we find, well, I know how I would find the next one, but how you would find the next one, which is the Owl Nebula.
I'd start with the Big Dipper.
Big Dipper. Okay, so let's go find.
Most everyone knows the Big Dipper, and it's actually up nice and high. There, you've got a really nice shot of it.
Here, I'll connect the dots so it's easier for people to see. Okay, so here is the
You've
Big
got
Dipper.
the bowl and you've got the handle there.
Mm-hmm. Okay.
And where the owl is actually you got to go to the bottom of the bowl and kind of blow up that region nearest that forward star.
Oh, is this it right here?
Yeah, right around in there.
Look at that.
It should be somewhere around there. If you blow it up more, there you got a green object. And that's the owl.
You're amazing. Yay. So for the rest of us, what you would do if you had stellarium is if you're new to the program, you would just click the little search window and then you would type in owl and then you would click on nebula and it puts little braces around it and you can zoom in. So, but then if you're at a star party like I would be with Kent, I would park my telescope next door and whatever he was looking at, I would practice looking at. And we did that for many, many, many years. And that's also where you start to remember these things now and then. So is this
a green laser really helps, I'll tell you.
Yes, it sure does. So is this a binocular object? What would you say?
It can be a binocular object, but it's not easy.
Okay.
I don't think my eyes are up to it. I'd go with a telescope and just kind of, you can see it's pretty close to like a line drawn between those two bottom stars, but it's closer to the top star. Mm-hmm. And I would just wander a little bit east and just hunt around. There's also another thing that'll kind of like a tip-off, is there's a edge-on galaxy called Messier 108. And if you stumble across that little edge-on galaxy, you know the owl is not far away.
No, it's not. Nice.
And so sometimes when I'm hunting it by star hopping, I'll see that little guy and I'll go, yeah, it's got to be a little bit further on.
Okay, awesome. How are you doing, Brian? Are you ready?
I'm good. We're ready.
Oh, well, let's do it.
Good.
Where are you? There you are.
I should actually share the correct screen there. And there we have it. This is a very magnified view of the Owl Nebula. Mm-hmm. And so perhaps you can start to have an idea of why it's called the owl. We've got these two dark or circles here, which are the owl's eyes, so to speak. Now, reminder, again, we're using a L Extreme dual band filter that's giving us a very narrow band of green for oxygen 3 and a very narrow band of red. And so you can see here, then we're getting a lot from the oxygen that's in this cloud of gas. Now, the Owl Nebula is an example of a planetary nebula. And this has occurred when a star close to the end of its life, as a red giant, started to puff out its outer layers. And that outer layer of gas then is expanded as the star then started to shrink into a white dwarf. So when it's a white dwarf, then fusion is no longer occurring. and it's essentially an ember of the former star that it used to be. But even as a white dwarf, it does put off light even in the visible range. And that's what this little dot is right at the middle, is the white dwarf star that put out all this gas. Now, just to give you an example too of how tiny this really is within the field of view. So here's a full view of what my telescope can see in the full wide view. And you can see then there's the little owl just kind of hiding away. And let's see, what else did I want to say? Now, this nebula is about 2,300 light years away, and it's estimated to be about 8,000 years old. So we think that star puffed out its layers about 8,000 years ago. And so then the amazing thing is, I'm going the wrong direction with my magnification here. The amazing thing is then this cloud of gas is still expanding. And so come back in a few 100,000 years and we'll see how much bigger it is.
Kent, did you have anything you wanted to add? Go ahead.
In 100,000 years, there'll just be a white dwarf all by itself.
It's true. Now, the current theories are too that this is similar to the end of the lifespan for our sun. But don't worry, you've got some time. We're talking in about about 4 billion years or so. And then,
actually, our star will leave the main sequence in about 5 billion years, roughly, I believe. Mm-hmm. And that's when it quits core burning hydrogen. It'll start going to shell burning, which makes it a lot warmer. So it starts actually expanding out. It's part of the step towards being a red giant. And so we've got plenty of time, at least for, at the end of the main sequence period, I think our sun will be twice as warm, or giving off twice as much energy when it leaves the main sequence. Our sun is getting hotter and hotter as time. I'm talking about long periods of time, but because there's, you're fusing hydrogen into helium, you actually end up with fewer particles to support the pressure, and so that ends up meaning that your particles have to move faster, so they're at a higher temperature to balance out the pressure against gravity, and eventually the sun is heating up and it's going to get hotter. I think about roughly a 500 million years from now, the sun will be hot enough so the Earth won't have an ocean, or our oceans will evaporate. And that's the latest thinking about stellar evolution.
Wow.
Yeah, it's fascinating to see the different paths a star can take as it's going through its lifespan, from a cloud of dust compressing into a main sequence star, and then the different ways it can go from a planetary nebula to supernova remnant, things like that. Mm-hmm. Let's talk color for a moment again. So one of the amazing things is how different elements can put off different ranges of color. And some of them are predominant depending on the element. So the reason that we're seeing something that's more blue-green with this nebula is because of the oxygen that's in this cloud of gas. Everything so far, I was showing you stellar nurseries that are rich in hydrogen. But now here we are at a planetary nebula with a star at the end of its life where it's fused most of its hydrogen into helium. But there's always other elements that are around as well. So this cloud that we're seeing is primarily from oxygen. And then, of course, then I'm using an oxygen 3 filter, which narrows the bandwidth even smaller to a little bit in the green range. So that's why this particular image will look green. When you see full visible images with the visible color range, then you'll start to get more of the blue from this nebula.
Actually, when you start fusing, you reach the helium point, then you start fusing helium and you get carbon, but also you can get oxygen.
Very cool.
And so actually, as a star is getting towards the white dwarf stage, it's actually making its own oxygen along with carbon. For the most part, it's like a carbon ball left behind. All the helium will get mainly fused towards the end. But a lot of the oxygen is probably produced by the star itself, because I think one of the pathways isn't just for carbon, but you can end up with oxygen for one of the fusion pathways.
That's so amazing how this works.
Yes, there's a lot to it. All right, let's do one more quick review. We've had a few people ask, where is this again? So let's do all of them very quickly. You and I are going for a walk outside. Are we? Yeah, I'm broadcasting that. Okay, go ahead and point when you see Orion. Tell me when you see Orion. We're going for a walk. We're going for a walk. Oh, there he is. All right, point to M42, which is the first thing we talked about, the Great Orion Nebula. You're going to look right in here. So you find his 3 belt stars. You're going to look in the sword, kind of the middle of the sword, and you will see something that looks like a smudge in your binoculars, or depending on how big your telescope is, it'll look more and more beautiful the bigger you go. And then if we looked at the flame and the Horsehead, so this was the easternmost star. Tom Smith told us it was Zeta, which was what I was looking for. And then Brian, you had the actual name, which I can't pronounce.
Alnitak?
Alnitak, yes, thank you. And we're looking right in here, and they're right next door to each other. We have B33, which is the Horsehead, and the Flame. And then we learned how to find the Rosette by taking these two here, Betelgeuse. Everybody was arguing how to say it, so pick your favorite pronunciation. And Bellatrix. So we're going to basically take these 2 stars and draw a straight line, go about the same distance, and then you just cruise around here with binoculars, and you'll find the Rosette right in here. And then the last, was that the 3rd, 4th? Rosette was the 4th. Okay.
Yes.
Oh, here we go. 5th one. I'm on a roll. All right. You tell me when you see the Big Dipper. See the Big Dipper. Most people can find this. There it is in the night sky. I think, Kent, you said the shopping cart was what people called it in.
Oh, no. The shopping cart was actually from Australia when you look at Orion.
Oh, Orion.
But this is, pretty much the Dipper. Also, it's called the Plow, I've heard used. I think that's mainly from England.
Okay.
But, we go the bowl, the bottom of the bowl, and, like drawing a line between the 2 stars, you get nearer to the star that's a little bit higher there, and you're circling the area. And actually, if you have a good chart, you take your binoculars and get a good idea where you're at. Then you put your telescope in and star hop over from like that corner star.
Perfect.
To the galaxy and the Owl Nebula.
Excellent. All right, great. Well, yay! Woohoo! Yes. So where's Brian? There you are. So how was that? How did you guys enjoy stargazing with us? Did you have fun? Let us know in the chat because we can't hear you. So tell us what you liked about tonight. We are really excited to be able to bring this is stuff we love to do. So we'll be able to share this with you. And we did have a couple of surprises. Surprise number 1 was you get to see Brian and his live telescope views. Surprise number 2 is you got to see Kent. Surprise number 3, we are thinking about one more virtual stargazing event for the season, and we wanted to check a date with you. We're thinking April 23rd, and we will have a slightly longer program with Kent, about 60, 70 minutes. So April 23rd, write that down because we haven't actually scheduled that, so that's tentative, so put that down.
Yes.
And we will send out an email. If you're on our email list, you'll get this. Make sure you do subscribe to YouTube and sign up with Central Coast Astronomy. You will be able to just be on our email list. We email you whenever we have events. And then we have another surprise. We are looking at public stargazing, and we are actually going to be sending out an email this week to you about public stargazing, and we need your input. So expect that email to be coming to you, and shortly afterwards we will be scheduling and sharing that schedule with you.
Now, the email's going to members, right?
That's right. I forgot. Interrupt me anytime. Go ahead.
Okay. Yeah. So if Central Coast Astronomy is an astronomy club in San Luis Obispo, California, and so far to this point, we've done some small in-person events, but we're looking at now, yes, indeed, going into in-person star parties and more public events in person. So club members, watch for an email asking some specific questions about that. If you would like to join Central Coast Astronomical, please visit our website for more information. You can see we have the questions email there. Just do centralcoastastronomy.org.
Yep.
Or www.centralcoastastronomy.org if you'd like. And then you can see more information on becoming a member. But even for star parties, though, you do not need to be a member of the club to join those. But if you want to be in the know on all that's going on and then enjoy some more benefits, then you definitely want to join the club.
Excellent. Yes, and it's all of, I think, $20 a year, maybe $25, I forget, but it's not very expensive. And
yes, membership is not free, but then we use those funds to help help support. Yes,
to do this.
Yes.
So you guys have enabled us to reach worldwide, and so being able to do these shows for you has been our pleasure, and you guys help us do that and keep the lights on. So, well, I guess in astronomy you don't want the lights on, but you know what I mean.
That's a good point. It's a catch-22, isn't it?
Let's see, Kent, did you have any last little tidbits you wanted to share? Anything else?
I was thinking we did good. Look at the time.
Yes.
We kept within our time restraint. It's been about an hour, so that's really good.
Yay. Oh, wonderful. Well, we got well with the time. For those of you who are looking for binocular recommendations, I see you guys have been going back and forth. Absolutely. Just grab a pair. They don't have to be fancy. Just get outside and look up. And that's really what we want you to be doing. So grab a pair of binoculars from someone that you can borrow them from. Go stargazing. You have 5 things to look at for tonight. And if you do have other questions that didn't get answered, you can always reach us at questions@centralcoastastronomy.org. And we look forward to communicating with you by email. And we look forward to seeing you in person over the summer. Hint, hint, hint. And so, yes, thank you guys so much. Brian, did you have anything else you wanted to share?
Well, I think thank you all for joining us. And thank you, Kent and Aurora. It's a really enjoyable time to be able to share these objects. And I look forward to next time.
Awesome.
All right. Thank you, Brian.
Thank you, everyone.
We have a request for a 3-hour show next time.
Oh, my.
Sure
You could just play. Actually, you could play us, right? Because we went about 90 minutes for 16 months straight. So you could binge watch.
That's a very good point. Yeah, remember, we've been doing this since almost the beginning of 2020.
Yes.
So all of those recordings are available for you to watch.
Yes, anytime. Here, I
can show you. They're on YouTube. All you have to do is search under Central Coast Stargazing, if I remember right.
Yes.
And they'll all pop up.
So we have centralcoastastronomy.org. This is our website, and you can watch all of the stargazing. Just because it says a certain year, October is October. And so you can go month by month stargazing tours, and you can take a look at that. And these are all the ones that we had done for an entire year. And so when that month rolls around, you're welcome to watch that as well. And so these are on there. These are members' work as well. So you can cruise around there at Central Coast Astronomy, Central Coast Astronomical Society. So, yeah.
Yes, awesome. All right.
Yeah, I think our very first one was March 2020.
Yes.
A long time ago.
I remember when I called you and you said, you want to do what? Like, I want to talk about the stars.
Well, then you said you have what? A rotary phone?
I said you can't do Zoom with a rotary phone, and I think the first 2 or 3, you had a rotary phone, and you were sitting on the couch. You were not watching. You were just talking to me as I was presenting, and you would say, no, make sure you do this, and make sure you look for that, and it was amazing. So Kent didn't use star charts at all.
I've advanced to a push-button phone, so that's a pretty good advance.
You have advanced. You have a push-button phone, so now it does work.
Yes.
So it does work. Okay, so we're going to wrap things up. Thank you guys so much. It's been our pleasure to be here with you. I will see you at the next stargazing event, whether it's virtual on April or whether it's live over the summer. Either way, please visit our website, centralcoastastronomy.org, and make sure you're on our list so we can send you an email for that information. All right, everyone, take care. Bye-bye.